Today we're going to walk through the copper cycle. The copper cycle is a series of reactions that takes solid copper and does a number of conversions into liquid and other solid states to return us to elemental copper. So our first reaction is starting with solid copper in the form of copper wire, and we'll watch the reaction with nitric acid. So here you can see the full balanced equation. Solid copper reacting with the nitric acid to form copper 2 nitrate plus the nitrogen dioxide and water. All right, so as we start the copper cycle, we are going to take our copper and we need to weigh it. So here I've already tiered the balance and we can see that it is zeroed out, ready to weigh our sample. All right, so we're going to open the door and we're going to add some of our copper. We'd like to get about 0.09 to 0.1 grams on here. So we'll add a little bit. That should be a little more than plenty. Let's take a little bit out. Let's see this one. All right, we will start with 0.1002 grams of copper wire. We'll transfer this to a test tube and now we can add our nitric acid. All right, so I've transferred our copper into this small test tube and we are going to see the reaction of the copper with the nitric acid. All right, so I'm just going to drop the nitric acid into my test tube. Here we go. And you can see that nice reaction, very reactive. We're doing this in the hood because you can see that brown gas escaping there. That is NO2 or nitrogen dioxide. All right, we are going to let that reaction go to completion. Very reactive reaction with the nitric acid. You can see that blue foamy color that is happening right there. And that is the reaction of the nitric acid with the copper. It's dissolving the copper and forming copper nitrate. I'm just going to pull down the sash on the hood just a little bit more. Finish adding our nitric acid. All right, you can see that nice blue color forming as the copper continues to dissolve in this reaction flask. All right, here we go. So you can see just the last bits of the solid copper turning into the copper nitrate. We're going to let this completely react until we don't see any more of that nitrogen dioxide coming off of the top. So we're just going to let that dissipate out into the hood here. All right, we'll come back in just a few minutes. All right, so our copper nitrate has been sitting here now for a while. You can see it's still reacting a little bit. Still have a little bit of that brown color coming off. I'm going to add a couple of mils of water just to dilute this a little bit and get the reaction going a little bit more. All right, so I'm going to add just a little water. And we'll mix that up here, and you can see this formation of the nice copper nitrate solution. We're going to dilute this now to 15 mils. Sorry, just trying to mix it just a little bit more there. All right, we're going to let that sit for a couple more minutes. And we will dilute this to 15 mils to start the next reaction. We'll also transfer it to a beaker. So the second reaction in the copper cycle is a reaction with the copper 2 nitrate that was formed in our first step with sodium hydroxide. This will be used to make our copper 2 hydroxide. So you'll need to balance the next chemical equation in our series. So take a look at the equation and make sure that you're writing the balanced equation in your worksheet. You'll also need to be sure to write down your observations of each reaction in your data table. This is going to be reaction 2. So here we have the copper nitrate solution, and I am just going to add a stir bar into the beaker, and we're going to put it up here on the stir plate right there, and we're going to turn the stir on. So this has the stir and the heat. We are only going to stir right now. All right, and the first reaction has the addition of sodium hydroxide. So here is our 6 molar sodium hydroxide, and we're going to add about 20 drops, is about 1 mil, and we'll see how that changes the solution. All right, so the reaction, you can see it has made this kind of solid, slurpy-like solution, right? The color has changed quite a lot as well. So you'll need to note those changes in your document. Okay, let's test the pH and see how that's changed as well. All right, so we need a basic solution. So I'm going to touch that to my pH paper down here. All right. And if we take a look at our pH paper, we can see down at the right side, a pH of 10 or above is the blue color. And we can see our pH paper is very blue. So indicating that we have a higher pH than a pH of 10. So we are ready to go to the next reaction. So the second reaction was very quick, and now we're on to the third reaction. So you'll notice in this reaction, we're not adding another chemical, but in this case, we're going to add heat. So in our equation, that delta H, so the Greek delta symbol is that triangle, is presented over the arrow, and this means that we're adding heat to the reaction. So again, you want to balance your reaction and note the changes that happen at this step. All right, from step 2, we made our copper hydroxide, which we now need to convert into the copper oxide. So we are going to dilute our sample first up to 100 mils. We're just going to pour water in, and this doesn't have to be really accurate. We just need it to get up to about 100. And we are going to turn on the heat on our hot plate. I'm going to put it up here at 6. And we are going to see what happens over time. Yep, I will come back in a few minutes after the reaction has started to heat up. We are at about 30 seconds of heating to 1 minute, and that is our monitoring for this step. And we are at about 4 minutes of heating. You can see our solution is starting to change now. Those nice fluffy blue particles are starting to turn black. And we need to continue heating until it is completely black and all of that blue color is gone. So only should be a couple more minutes now. And we are very close here. I am not seeing any more of the blue color. So I think we have completed the copper oxide step. I'm going to pull this off of the hot plate and set it down onto the bench top. So I'm just going to take it, whoops, sorry, and set it down over here. All right. And we just need to remove that stir rod, and then we'll let the sample settle out of solution. So you can see again all those black particles. You can see that solid precipitate. That is your copper oxide. So it has changed form again. All right, I have the magic magnet. I'm going to pull that stir bar right out of the solution, and we'll let our solution cool now. And then we can do the decanting step and move to the next reaction. Okay, so the fourth reaction, we are going to dissolve our copper 2 oxide using sulfuric acid to form the copper 2 sulfate. So that reaction is shown here. So you'll need to balance that reaction, and you will need to describe what happens when we actually set that reaction up. And then aluminum doesn't react, which is our next step in part 5. We're going to add our aluminum to the reaction. But it doesn't react very well with the sulfate ion. So we need to add a source of chloride ions and essentially convert the copper 2 sulfate into the copper 2 chloride. So we will add some hydrochloric acid at this step as well. So make sure to balance that reaction and describe if anything changes when you add the hydrochloric acid. All right, for this part of the step now, we need to decant off the liquid and only keep the solid. So let me see if I can prop my camera up here so we can take video of this. I need 2 hands for this part of the experiment. All right, so we've got our beaker that we are going to decant into. And I'm going to move my stir bar out of the way. And I'm going to rinse off the policeman. So my glass rod is clean, so I can decant into the beaker here. All right, so to decant, I'm just going to pour my solution down the glass rod so that it will go into this beaker. And we're just going to go slowly, making sure that I don't pour off the copper oxide, which is the black solid. You can see a little bit of the copper is floating up pretty high. So it's hard not to pour off some of it, but I want to keep the bulk of it in the flask. All right. So I won't be able to get off all the liquid at this step, but I'm going to try to get most of it off of there. All right, so my final solution looks like this. You can see I do still have some black up at the top here. We'll wash that down in the next couple of steps and make sure that we recover that copper. We need to get that back. All right. And you can see the liquid. I do have a little bit of copper in there, right? So this is a step where I may lose some of my yield because some of that copper is floating around in there in that solution. All right. When you do this, you do it better than I do it. All right. So our next step is to add 8 mils of our 3 molar sulfuric acid. So I'm just going to fill up my cylinder here to get 8 mils. All right. And now I'm going to add this solution to the copper oxide. And we're just going to swirl to mix. This is actually my favorite step in this reaction. All right, so do you see anything going on? Starting to get a little bit lighter brown there. Right, and we are hopefully dissolving here. And this is like magic. All right, so we've dissolved our copper oxide through its reaction with the sulfuric acid. You can see I still have that black stuff up there. We'll get that down here in just a minute. In fact, I'm just going to use a little bit of water to wash that down into my reaction. All right. And we put that down and let's swirl, make sure it's all dissolved. Okay. All right, so there's the step from copper oxide, reaction with sulfuric acid, making our copper sulfate. Now we're going to add a little bit of HCl into our reaction, or hydrochloric acid, because that will allow our last reaction to occur. So we're substituting essentially the chloride ions for the sulfate ions, and then we can get reaction with our aluminum foil. All right, so I'm going to add 2 mils of 6 molar HCl, or hydrochloric acid, to my reaction. And I did wash my little cylinder here before adding the hydrochloric acid to it. You always want to wash your glassware in between reaction steps. That's very important not to mix chemicals. You don't know always how they'll react together. All right, so I've got 2 mils of my hydrochloric acid. We're just going to add that to the solution. This is just going to dissolve right now into the solution. So I'm making the hydrogen protons and the chloride ions in the solution. This has not really changed the copper at this point. The copper is floating around in there as copper 2 ions. Right? My chloride ions are floating around and my sulfate ions are floating around. But the chloride likes to react with the aluminum foil more than the sulfate does. All right, so let's go ahead and weigh out our aluminum foil. All right, we've made it to the 5th reaction. So this is the last reaction step, and then we'll still need to dry down our solid copper and weigh it again. But for our 5th reaction, we are going to take our copper 2 chloride that we have in solution now and react it with the solid aluminum foil to help create the elemental spongy copper. This is kind of a brick red color, and so be on the lookout for that. And in the process, we also form the aluminum chloride. So that's the first reaction that we have listed up on this slide. There's also a second reaction that is there. That's a side reaction that happens with the aluminum foil and the hydrochloric acid. So try to balance both of those reactions at the same time. All right, so I've added the stir bar back to my solution. Again, this is the solution containing the copper sulfate and the hydrochloric acid, so copper chloride as well can be in there. And all of the ions are currently dissolved and dissociated in there. So we're going to put this back onto the stir plate. You can see I also have a snorkel over this reaction. This reaction will emit some hydrogen gas fumes, and they can be kind of unfun. So I've measured out the amount of aluminum foil that I need. I didn't show you this on the balance because you have to calculate that. So hopefully you'll get the right answer there. And I'm going to tear it up into smaller pieces and then add it into my solution. All right, I've torn it up into smaller pieces. This will let me get more surface area for the aluminum foil to interact with my solution. So I'm going to add it here into my beaker. All right, and here is the reaction with the aluminum foil. So we're spinning around here. All right, I'm just going to slow this down so that you can see this reaction going on just a little bit better. You can see, maybe I'll turn it off for a second, just so we get a feel for what's going on in here. Okay, so here, let me get closer up here. All right, so if we're looking right at this piece of aluminum foil, you can see that there is a spongy red color that's forming on the foil. And you can see lots of bubbles being evolved here as this reaction is taking place. This is the gas that's evolving from the reaction. And I am trapping it up here in the fume hood because it's unpleasant. Okay, so right here, you are getting the aluminum foil to go into solution and replace the copper. So the copper chloride is now turning into solid copper, and the solid aluminum is replacing in that reaction and is becoming aluminum chloride. So that is the reaction that's going on at this step. So I'm going to go ahead and turn on the stir bar again and let this reaction go to completion. And how do I know when it's complete? Right now you can see that blue color still in the solution. The blue color is the copper. So once this reaction is complete, there should be no more blue color in the solution. It should all be that solid spongy red color that's forming on the surface of the aluminum foil. So let's go ahead and return on the stir bar here. All right, and my sample is now spinning, and you can see the formation of that spongy red copper. All right, we're getting pretty close here. Almost all of that blue color is gone, and we will be able to go to our next section where we need to filter our spongy copper solid back out. All right, so in this last section, we actually have to recover the spongy copper and determine how much we got back after we manipulated all of these copper steps. So to do that, we are going to filter out the spongy copper onto a piece of filter paper. So I'm giving you the mass of the filter paper currently as 0.4127. That is weighed out before we do the filtering. And then after we do the filtering and recover that copper, the mass of the filter paper with the copper you will see is 0.4918. So you need to determine what is the mass of the spongy copper. You need to subtract off the filter paper weight. So that's our first task. And then we need to calculate the percent recovery. So the percent recovery can be found by taking the mass of the spongy copper that you identify above here, and then divide it by the mass of the copper wire at the beginning. You're going to multiply this by 100, and that will give you the percent recovery. All right, so let's take a look at these final steps in our process. All right, now that all that blue color is gone, we need to go ahead and filter our copper. So I'm going to pull out the stir bar again, and we're going to decant our solution. we are going to decant our solution off of there. Okay, so here we have our spongy red copper that we've made. Okay, so it's down here. And I'm gonna set up my camera so we can do the decanting again. Back out. All right, and you can see that most of that blue color that we used to have in there is gone. I think the color of the bench behind was kind of hiding that a little bit. And we can go ahead and decant. Let's go ahead and we're just gonna wash the copper now to get off any remaining acids from our solution. So we get a nice neutral solution back. We're just going to rinse with the water a couple times. And decant again. And the spongy copper really does like to stay at the bottom of the flask. So it's much easier to decant this one without pouring it off into the beaker. All right, so I'm gonna rinse just one more time with some water. All right, and we are going to leave it just in this water solution until we are ready to filter. So setting up the filter, we are going to use an Erlenmeyer flask, and we are going to set up our filter system in here. And so I'll show you how to fold the filter and to set up your flask. So first, anytime you're filtering by gravity, right, and you're using a vessel like this, you can see this filter really seals around the Erlenmeyer mouth, and that will cause the filter to not be able to exchange air, and it will not be able to draw down the solution. So I like to just take like a little piece of paper, or this is paper towel in this case, and I use it to kind of prop up the filter. And what it does is it makes a little gap in there, and so that allows the air to move in between the flask and the air in the room. And so that will make sure that my solution can actually go through the filter paper. So you need to make sure that you have air exchange anytime you're filtering. All right, let's go ahead and fold the filter paper. Let me go grab a filter paper. All right, so this is my filter paper. I have weighed it. You need to weigh it before, because we're going to filter the copper onto it, and then we're going to dry it, and we'll weigh it again, and we can subtract out the weight of the filter paper. So to filter, I am going to fold my filter paper in half, and then I'm going to fold it again into quarters here. All right, and then when you open it up, right, you can open it in half, but that's not really helpful. So I'm going to put 3 sides together and then one side here, and you can see I made just a little basket that I can use to catch my sample. So I'm going to set that up in the filter. It doesn't really like to stay too much, so I'm going to wet the filter paper down just a little bit to make it stick in there. And this is just water. All right. And let's just take a look at that. So I just wet the filter paper. You can see it's draining now, but that will make it stick nicely to the sides of the filter. And you can see the drain is still working, and the solution went into the flask. All right, so let's go ahead and filter our copper. To get the copper to come out, I'm gonna swirl and just pour right into there, because it will want to stick to the bottom. So I may have to do this a couple times. I think I got most of it there. So you can see I still have a few little pieces of copper. I'm gonna rinse this one more time. You can see the filtering is going well. And swirl and pour. And I think I've got one more little piece. All right, I think I've gotten most of the copper out. Maybe one little piece like straggler in there. Get out. Okay. I don't see any more remaining now. All right, let's take a look at what it looks like in our filter. All right, so there is my copper. So you can see it's mostly at the bottom of the filter paper. There is some straggling on the edge there. So I'm going to rinse now with some acetone. All right, so here is my acetone, and we're just going to rinse the copper with some acetone. And I'm just going to try to guide it and get all those little pieces down into the middle of my filter paper and rinse it down there. All right, so why do we rinse with the acetone? The acetone has a lower boiling point than the water does. Water is actually quite hard to get off of your sample, and it has a lot of weight. So we need to be able to dry our sample fully, and the acetone will just let us dry this sample a little bit faster. So once, I'm going to let it sit here for just a minute, and then we'll pull it out of the filter and we will start to dry it on our hot plate. All right, so I've got a piece of paper towel, and I'm just going to peel out. You can use forceps for this, but you don't really need them. I'm going to peel out the filter paper, and now you can see the filter paper here. I'm going to place it in the paper towel, just like this, and I am going to flatten the paper towel around it, and I'm going to take off as much of the solution as I can. It's mostly the acetone that's in there, but probably some water as well. And I just want to pull off as much of that solution as possible. Right, lot there. So I'm just going to move it one more time, and we're going to fold it in one more time and just try to dry it here a little bit. All right, so that's probably as dry as we can get with the paper towel. Now we're going to open this up, and I have an evaporating dish here. It really is clean, it just has some stains in it. And I'm going to open up the filter paper now so that it can dry a little faster. And I'm going to press it just into the bottom. So you can see the spongy copper right in the evaporating dish. And I'm going to place this now up onto the hot plate. All right, so we're on the hot plate. And I'm just going to turn this to a setting of 3 on my hot plate with the heat, no stirring. And I can move the snorkel out of the way now. And you can see my sample down here. It looks really nice in that spongy red color. That is my solid copper. I want to watch it because I want to stop this as it dries and doesn't get too dry, right? If I heat it too much, I could reform that copper oxide, which was black in color, and that weighs a lot more when it takes in that oxygen atom. So you just want the copper. This is elemental copper that we've recovered back, and it's called spongy red copper. All right, so that is near the end of the experiment. The last bit would just be to weigh it, and we will come back and we will get a weight for our copper so that you can see that. All right, so the final weight of our spongy copper with the filter paper is 0.4918. So the weight of the filter paper alone was 0.4127. That's 0.4127. All right, so you can subtract off the weight of the filter paper to get the final weight of the copper. And with that, I hope you've enjoyed the copper cycle. See you again next time.